Hello, today's section is 4.2, dealing with perpendicular and angle bisectors. So up here I've drawn bisect man. So bisect man is going to play an important role in this section today. So it is very important that we know what bisect means. So bisect man's superpower is to bisect things. So when he bisects things, he goes straight down the middle. So he cuts it and separates it into two congruent parts, just like he did with segment AP and PB. Those are now congruent. Also, AC and BC will be congruent as well. So that's the first theorem that we're going to talk about today. So we're going to talk about a few theorems. First one is the perpendicular bisector theorem. So if we have two little triangles being cut by a bisector and AP and BP are congruent, then that means these sides have to also be congruent. The converse of that, or the opposite, means that if we already know that this and this is congruent, so AD is congruent to DB, and we already know that AP is congruent to BP, then that tells us that CP has to be an angle bisector, or a perpendicular bisector, not angle bisector. So if it's a perpendicular bisector, when two lines cross and they're perpendicular, that means they form 90-degree angles. So that's what perpendicular means. And bisector means it goes right down the middle. So when it cuts through it, it'll create two congruent lines. So in example 1, we need to use that information. So line BD is a perpendicular bisector of segment AC. So that means bisect man. It's cutting right down the middle. Bisect man cuts through it. So that means that we know BC and AB are congruent, and also DC and AD are congruent. So if those two sides are congruent, if I want to solve for x, 3x plus 14 has to be equal to 5x. So subtract 3x. 14 equals 2x, so x will equal 7 if I divide both sides by 2. So again, notice, I want to reiterate this again. I know I've said this multiple times before in previous lessons. We are not done because they did not ask us just to solve for x. What do they ask us for? What is AD? Whoops, didn't mean to cross through it. So AD is this 5x length right here. But if x is 7, then AD has to equal 5 times 7, or 35. So AD is 35. So again, make sure you read what they ask you to find. In example 2, BD is the perpendicular bisector of segment AC. And then find CD. So this is what I have to find this time. So again, bisect man goes through the middle of this triangle and cuts it into two equal congruent halves. So BC and AB are congruent, and we also know that CD and AD are congruent. So 7x minus 6 has to equal 4x. So I'll subtract 4x on both sides first. So 3x minus 6 is equal to 0. Add 6 to both sides. So 3x equals 6, so x has to be 2. So again, we're not done. We're trying to find CD. CD is this length right here, so 7x minus 6. But I'm going to substitute 2 in for x, since I know 2 and x are the same. Oops, not equals. So 14 minus 6, so CD has to equal 8. In example 3, line WX is the perpendicular bisector. So what does it mean to be perpendicular? So when two lines cross, they form 90-degree angles. So that means perpendicular. Bisect. What does that mean to bisect? It means it cuts right down the middle and separates things into congruent parts. So WX is the perpendicular bisector of segment YZ. So that means if YZ is being bisected, YX and XZ have to be congruent. We already know that YV and VZ are congruent because they're both 25, and this is a perpendicular bisector. And then we also know, since these two, YX and XZ, are the same, we also know that WY and WZ have to be the same as well. So what segment lengths in the diagram are equal or congruent? Well, YV is congruent to ZV, YW is congruent to ZW, XY is congruent to XZ. So I'm just naming everything that we know is congruent. I don't think there's anything else in there. And then is V on line WX? So the way that we can tell if V should have been on line WX, since this is a bisector, the WX line is a bisector, if it creates two congruent lines or line segments on the opposite side of V, then V is on that on the line. Since these two, YV and ZV, are both the same length, then that means V has to be part of the bisector. That's going to be important later on in this unit, like when we take the test possibly. So V is, yeah, or you can say yes, V is on WX. All right, moving on to the next page. So we got some more theorems. So this is the angle bisector theorem. It basically says the same thing. We got bisect man cutting through that shape and creating two congruent angles. Also notice that BD and BA are perpendicular to each other. So this line and this line are perpendicular because they form a 90-degree angle. Same with DC and CA. They form 90-degree angle, so they are perpendicular to each other. That's important in this. So these two angles are congruent. These two angles are 90 degrees, so that means red is a bisector. So the converse is saying what I just said. So if I know that these two sides are congruent, and we got 90-degree angles, this has to be a bisector, which would also make these two congruent. So we're going to use that information in these next few examples. So example 4, find the value of x. So we know this is a 90-degree angle. 90-degree angle, and these two are congruent. So that must mean that AD is a bisector. So bisect man goes through. So what do we know about BD and CD? These two have to be the same or congruent. So 5x has to be equal to 6x minus 7. So if I subtract 5x on both sides, I get 0 equals x minus 7, add 7. So x equals 7. So this one asks us to find the value of x, so now we're done. On the next couple exercises here, find the value of x. So again, we got a 90-degree angle, 90-degree angle. These two angles are the same. So that tells us that this is a bisector. So bisect man goes through, and he always makes things congruent. So x has to equal 15. So that one was easy. Number 2, this segment and this segment are congruent, and we got 90-degree angles. So this must be a bisector. So then what does that tell us about these two angles? They have to be congruent. So I'm going to do number 2 down here. So that means 3x plus 5 has to be equal to 4x minus 6. So we just solve for x. So I'm going to do 2 steps in one. I'm going to add 6 to both sides. I get 11. And subtract 3x on both sides, so I get x. So x equals 11. And number 3, so again, we got a bisector because this is a 90-degree angle, 90-degree angle. And those two angles are congruent. So again, just to remind you, when we have 90-degree angles, that means this line and this line are perpendicular. So that's how we get 90-degree angles, when two lines are perpendicular. We also know now that those two segments are congruent. So 5x has to be equal to 6x minus 5. So I'm going to add 5 to both sides and subtract 5x. Hopefully, I'm not skipping too many steps there, but x should equal 5. And then finally on the last one, number 4, do you have enough information to conclude that QS bisects angle PQR? So I want to know if this is a bisector right here. Is this a bisector? Well, we know that these two segments are congruent, but we need at least one other piece of information, and we don't have another piece of information. So if I go back up here, remember we always knew two things. We either knew that these two angles are congruent, and this is a 90-degree angle, or we knew this segment was congruent to this segment, and these two are 90-degree angles. Since we don't have the 90-degree angle, we don't know that these two lines are perpendicular. I need these two lines to be perpendicular. We cannot say, so the answer would be no. We don't know if PQ is perpendicular, so it's the perpendicular symbol. Oops, I don't need to write 2 there. We don't know if PQ is perpendicular to PS. And you could say the same thing with RQ and RS. So we don't know that those two things are perpendicular, so we cannot say that QS is a bisector for sure. And it doesn't want to stop.